In session 3, we used another way of reducing pollution to acceptable levels, namely a cap and trade scheme. Right, so the government set a cap on pollution. I said, so 30 permits, i.e. 30 deals can be made, no more. That was based on some rough calculations on the number of deals that we should have. And we then auctioned off those permits. Well, session 3 in an online environment did not go exactly as planned. So I think that the auctions did not really end up in the hands of those that value them the most, i.e. The sellers with the lowest seller cost, the most efficient suppliers. But I hope you got the idea that whether you allow for trading of the permits or whether you auction them off, eventually the permits end up in the hands of suppliers that value them the most, i.e. not in the hands of other suppliers, and those suppliers cannot make a deal, right? I.e. the inefficient suppliers who would not add much surplus to overall welfare anyway, they're out. And that's exactly what we want to achieve. Total surplus was pretty high in this session, and again, so what we did is that we got the revenues from the auction and then shared those revenues equally among all the citizens of this society. So the pollution damage was exactly compensated. And that is the idea. So that also gives you an idea of the average price of the permit. That should be at least 20 if the market works well. Let's put this in terms of graphs that I introduced in the first week of externalities. So then remember that in this graph, so in the second part of the lecture, we discussed providing incentives for producing greener, and on the horizontal axis we had then the amount of pollution reduction, i.e. the number of trades killed. In our context, on the vertical axis we have dollar value. So how would the marginal social benefit from pollution reduction look like? Well, what is the benefit to society of reducing pollution? Well, in this case, the answer is simple, because every deal adds $20 in pollution damage. So every deal that you prevent from being made prevents this $20 in pollution damage. So the benefits, the marginal social benefits of reducing pollution is 20 and remains 20. So that's a flat curve, right? So here you go. Marginal social benefits is 20. Next, we need another curve. So what are the costs, the marginal costs of pollution reduction? How would that curve look like? Well, that is basically what does it cost to suppliers to reduce pollution? Well, in our case, reducing pollution can happen in only one way. Is by not making a deal. What we then forego is the profits, the surplus that the supplier would make based on the deal. Right, so here we go. The marginal social cost curve is the missed profits from deals, and it's upward sloping because we order it. So to the left are deals with very low profit for a supplier, and to the right are deals with very high profit. So to the left are basically the very inefficient suppliers, and to the right are very efficient suppliers. And you may feel this coming, that we may not want to kill off even the most efficient suppliers. right? But that also depends on where the marginal social benefits are equal to the marginal social costs. So that's exactly how much pollution reduction we want. And we do not want to go beyond that point. So we don't want to kill all pollution, because if we go beyond that point, where the red arrow is, then actually we kill more surplus than we save in pollution damages. So then that's not worth it. And so we want to be exactly at this point. So that is the maximum of missed profits that we want to allow. Then the price, the average price of the permits is going to be roughly 20 if the market works well, if the auction works well in our case. And then the level of production is going to be much lower than 47 as in the free market with a negative externality. So around 2 in session 1. So it's going to be more like 20 to 30, and in our case actually we had 22 trades in session 3. I think, when everything worked out well, so if it would have been in class, we would have been closer to we would have had closer to 30 deals anyhow. So we kill something like 25 deals, and remember, on the vertical axis is not a number of deals but the reduction in pollution. So we reduced pollution, we reduced production, we reduced the number of deals by 25. And that is then optimal. To conclude our discussion of the experiment, so whenever you see news about we got record GDP growth, the economy is doing really well, always realize that there is also another side of the coin, namely that economic activity usually goes together with a lot of negative externalities. And if you also take those into account, then the picture looks a lot less favorable. It may even be that a certain activity, we would be better off not conducting certain economic activities, because if we really look at the numbers, then the surplus is actually lower than the environmental damage that we do. And whenever we are faced with this dilemma, so to what level should we reduce pollution, or should we sort of completely kill this industry or no? Then you want to not randomly kill economic activity, but you want to only kill economic activity that adds less surplus than it creates damage to society. And that we can do that, as we learned in experiment, by way of a tax, but also by way of a cap and trade scheme.